Yeah. We finished this one.
Okay, and what about this? This also, no?
This one also we finished. Yeah.
This? No.
1 second. No, we didn't finish this.
Okay. So let's just start from here itself, right? So
Okay.
the question is chemical properties of metals, right? So what happens when
Yeah.
metal burn in air? So see, most metal oxides are water insoluble, right? So metal oxides, when metal is being mixed with the burn in the air, what happens? They form metal oxide, right? So most of the
Okay.
oxide, they are water insoluble, like they don't get dissolved in the water. But like there are some sodium oxide, potassium oxide are there that are soluble to form alkalis, right? So
Yes, ma'am.
if someone will ask you the question that all the metal oxides are water soluble, you will say no. Most of the metals are water insoluble, but there are some metals as well that are soluble. So both. Most are insoluble, but few are soluble as well. Clear? So it is
Got it.
sodium oxide plus hydrogen is giving you sodium hydroxide. Potassium, potassium oxide plus water is giving you potassium hydroxide, right? And see, all
Yeah.
the metals, they show different reactiveness toward the oxygen. So sometimes maybe sodium will be highly reactive, potassium will be less like that. So not every metal is of same, have same reactive series. They basically depend on person to person how they are behaving. Like not person to person, depends on the metal to metal how they are reacting with the thing. Then metals such as
Thanks.
potassium and sodium react so vigorously that they catch fire if kept in the open. Hence, they are kept in kerosene. So over here, a question comes: why potassium and sodium are kept in kerosene oil? Why not in open? So I told you potassium and sodium, they are very reactive. So they can see in
Yeah.
air, they will easily react and they will catch fire. Right? So that's why they are
Got,
kept in kerosene oil so that they don't catch fire. Clear?
got it.
Okay. Now coming to the next one, this. See, every metal is different and everyone, they change their temperature as well. See, for example, you are sitting here. Suddenly, if I start burning something, your temperature will increase, right? So
Yeah.
similarly, metals are basically burning. So of course, there will be difference in the temperature as well. So at ordinary temperature, the surface of metals such as Mg, Ai, Zn, Pb, etc. are covered with a thin protective layer of oxide. It prevents metal from further oxidation, right? So temperature changes, but there is a layer in all the metal that is helping them from the further oxidation. Remember one thing, iron does not burn on heating. No matter
Got
how
it.
much you will see, you are burning the iron. There is not heat. But iron filling, the particles, the powder form, they basically burns vigorously and a sprinkling firing you can see that comes up. Right?
Got
And
it.
coming to copper, this is the copper. Copper does not burn, right? But the hot metal is coated with a black layer, right? So over here,
Yeah.
for example, this is the metal, right? So what you will do, you will put a copper coating because copper does not burn, right? So in a metal, you will put
Yeah.
a copper coating so that it don't burn, right? And then
Got
coming
it.
to next one, silver and gold do not react with oxygen even at high temperature. So no matter what temperature it is, silver and gold, they will not react. Okay. So
Got it.
first you will write these two and then I'll scroll.
Okay. Teacher, finished writing. Ma'am, I'm done writing. Ma'am, I finished writing those.
Now coming to the next one, this. Okay, when the metal is burning, I already told you, for example, this is a metal. So it has a layer, right? So process of forming a thick layer, which is oxide layer of aluminium. Why, ma'am? Why we need this? This is basically a process of anodizing. So what you will write? You will write what is anodizing. So anodizing is basically to make a thick layer of oxide of aluminium in a metal so that it don't get corrode, right? And in this, a clean aluminium article, which is anode, is electrolyzed with dilute H2SO4, right? And then the oxygen evolved at the anode react with the
Got it.
aluminium to form the oxide layer. And this layer is also known as dye. Okay.
Got it.
And after that, coming to the next part. So the question is, ma'am, now that ma'am, what will happen when the metal will react with water? You already know when the metal will react with air, what will happen, right? It will form
Yeah.
water oxide and all that, then water. So see, some metal react with
Yeah.
water to form metal oxide and hydrogen gas. Okay, so when metal react with water, they form metal oxide plus hydrogen. Metal oxide plus water gives metal hydroxide, right? So metals like potassium and sodium
Yeah.
react violently with the cold water. Very, very important. So potassium and sodium, they react with the cold water, and this process is called exothermic. Why? Because heat energy is also released. That's why they are exothermic reactions. Clear? So these are the examples. Potassium
Okay.
plus water will give you potassium oxide plus hydrogen plus heat energy. Same sodium like that. Then coming to the next part over here, this. What will happen? Calcium react with water less violently. Over there, I told you sodium and that potassium, they were reacting highly. But calcium is a metal that react less violently, right? So over here, they don't catch fire because it
Yeah.
is less reactive, right? And remember one thing, calcium always floats because hydrogen gas bubbles
Yeah.
stick the metal surface, right? And now coming to magnesium. See, magnesium
Yeah.
also reacts with water. But remember, there are two types of water. One is the hot water and one is the cold water. So magnesium reacts with only
Oh.
hot water, not with the cold water, right? And it also floats because H2
Yeah.
gas bubbles stick to the surface. Clear?
Got it.
First, you will write this. You will write what is anodization and you will write the entire. Okay?
Okay. Thank you.
And just draw this diagram. This
Okay. Teacher finished with this one. Teacher, finish writing those. Ma'am, I finished writing those.
Okay. Now coming to the next one, this one reacts with water. So metal like aluminum, iron, and zinc react with steam, not with cold and hot water. So aluminum, iron, and zinc, they don't react with water. They only react with steam. Clear? Not with cold and neither with hot water. So Al plus H2 will give you AlO2, O3, H2 like this. And metals such as lead, copper, silver, they are something that they will not react with anything like water at all. Okay. So this is the reactivity series: sodium, potassium, calcium, magnesium, aluminum, and iron. Clear?
Got it. Yeah.
Now over here, what will happen if metal with react with acid? Okay. So when metal react with acid to give salt and hydrogen gas, metal plus dilute acid, salt plus hydrogen. Okay. So when metal react with acid, they give you salt as well as hydrogen. But remember one thing, all metals do not react in the same manner. See, these are some metal: aluminium, copper, iron, lead, magnesium, and zinc. What we are doing, we are reacting them, and you can see, though they are forming salt and hydrogen, but there is a difference. Now, what is that difference basically? Magnesium shows faster reaction, clear? And hydrogen bubble formation and record highest temperature, right? So over here, it keeps on decreasing. Magnesium highest, then aluminum, then zinc, then iron. But there is a copper who do not react with dilute HCl, so bubbles are not formed, and there is no change in temperature. Okay. And remember one thing, hydrogen gases not evolve when metal reacts with nitric acid. Acid are different type. So if it is nitric acid, then it will not react, give you hydrogen gases, right? It is because it's a strong oxidizing agent. It oxidizes the
Got
acid
it.
water itself and reduce the nitrogen. But magnesium and manganese react with very dilute dissolving H2. Clear? So we got to know that, yes, ma'am. See, in a class, there are 10 students. Teacher is teaching you the same thing, but someone will score very high, someone will not score good, right? Because of their capacities. Similarly, the metals, they will react with acid, though they will form salt and H2. But some will react faster, some will change the temperature, some will react slower, they will not change the temperature like that. Okay?
Got it. Teacher, finish this. Teacher, finish writing those.